right, let's dive into this paper that has everyone talking, YOLOv12. Attention-Centric Real-Time Object Detectors.
Yeah, this is pretty groundbreaking stuff. I mean, it's the newest version of the YOLO family, obviously, but
It's really changing the game.
yeah, it's not just like, oh, here's an incremental update. This is
Exactly.
a paradigm shift.
Yeah, they're bringing attention mechanisms into real-time object detection, which is something that people have always said wasn't really possible
And you know why they said that?
because it's too computationally expensive.
Yeah, exactly. Too much computational overhead, especially for,
Real-time applications.
real time. We're talking about self-driving cars, robotics, anything where a few milliseconds could make a huge difference.
Exactly, and that's why CNNs have really been the king in this area.
Yeah, they've just been so reliable and fast, and
They get the job done.
they get the job done.
But attention has been amazing in NLP, but people thought it was too computationally heavy for these kinds of tasks.
Right, and the reason is that attention requires looking at the relationships between all the different parts of the data, and with images, that's a ton of pixels.
Exactly.
So you've got this massive computational load.
Yeah, so how have they actually made attention work in real time? Because that's the real headline here, right?
So they've tackled the two main things that have held attention back, and it's computational complexity, right? Just the sheer amount of computation and memory access bottlenecks.
So they've made it less resource intensive.
Yeah, exactly. They found ways to make it much more efficient.
Okay.
And it's actually a really cool analogy. I think if you think about it this way, traditionally, attention was like you're trying to find a book in a massive library, but the filing system is chaotic. You're
Yeah.
jumping around, there are delays, it's just a mess.
Yeah.
CNNs, on the other hand, were more like accessing a really well-organized library. Everything's where it's supposed to be. Streamlined, super fast, and they made attention into that.
Oh, okay. So how did they reorganize this chaotic library of information?
Well, they introduced a couple of really clever things. First of all, area attention, A2.
Yeah.
And imagine like dividing that massive library into smaller sections.
Okay.
Instead of searching the whole thing, you just focus on the relevant section.
So they're breaking down the problem.
Exactly. It's a simplification, but a really smart one that reduces the load without sacrificing accuracy.
Oh, very cool.
And then they also introduced this thing called Residual Efficient Layer Aggregation Networks, or R-ELAN.
Okay.
And this is about improving how the model actually learns and processes information.
Okay, so R-ELAN is all about learning.
Yeah, and you see these traditional network architectures, especially for attention, would often struggle with stability as they got bigger and more complex. Imagine building a skyscraper on a shaky foundation.
Yeah, it's all going to come crashing down.
Exactly. R-ELAN connections are like support beams. They stabilize the training process.
Okay, so it can handle the complexity of attention.
Exactly.
No, that's really cool. So they've taken what was kind of like this wobbly attention model and made it much more
robust, more stable.
Yeah.
And they've done all this while still keeping that YOLO framework, which is known for its speed and efficiency.
Yeah, so they're not reinventing the wheel.
Not at all. They're just supercharging it with intention.
Okay, I like it. So we've talked about the computational complexity. We've talked about R-ELAN and how it helps it to learn. But what about these memory access bottlenecks?
Right. So remember, attention kind of jumps around in memory, causing all these delays.
Yeah.
Well, they use this technique called flash attention,
Okay.
which basically streamlines how that attention accesses and processes the information in memory.
So it's like optimizing the traffic flow.
Yeah, exactly. It's making sure everything moves smoothly and efficiently. And it's a key part of making YOLOv12 real time.
Okay, so they've got area attention, they've got R-ELAN, they've got flash attention. It sounds like they've really addressed all the big problems here.
Yeah, they really have. And they've also made some interesting choices with the architecture.
Okay, like what?
Like sticking with the hierarchical design of YOLO instead of going with a plain vision transformer, which,
That's what everybody's talking about right now.
Sure is.
Vision transformers.
But their experiments showed that the hierarchical approach with those features being processed at multiple scales actually works better in this case.
So, going back to the classics again.
In a way, yeah. Sometimes the tried and true methods, especially when you combine them with these really clever new innovations, they just work.
So they've taken this classic approach, they've added some really cool cutting edge stuff.
Yeah.
And they ended up with this super powerful and efficient model.
And the results are really impressive. I mean, it beats its predecessors.
No surprise there, but how does it compare to other state-of-the-art models?
It's giving them a run for their money, let's just say. That YOLOv12S, which is the smallest version of YOLOv12, actually beats RTDETR, a really highly regarded end-to-end object detector. And it beats it in both speed and efficiency.
So it's not just faster, it's more accurate as well.
Yes, exactly. And they have these visualizations in the paper, these heat maps, comparing it with previous versions, and you can see a clear difference.
So what do these heat maps show?
It's showing that YOLOv12 has this much clearer and more precise understanding of the objects in the images.
So it's not just blobs, it's actually understanding the shape.
Yeah, it's like the difference between seeing something blurry and seeing a high-definition photo.
Yeah.
That level of precision is really important for tasks that require a really detailed understanding of the scene.
Okay, so we've got the technical innovations, we've got the performance, but what does this mean for real-time object detection?
I think this is a real turning point. This paper demonstrates that attention can be competitive in this real-time domain, which opens up so many possibilities.
So it's not just incremental improvements, it's like a whole new way of thinking about this.
Yeah, exactly. And the applications are vast. I mean, think about it.
Yeah.
You could use this in security systems for more accurate threat detection, healthcare for real-time analysis of medical images.
I can see it in sports analysis too. You know, tracking athletes' movements
Yeah.
in real time, analyzing their performance.
Oh, yeah, and AR and robotics.
Yeah, it's giving them a much deeper understanding of the world.
Exactly.
So this is really interesting, but could this work on like a smartphone or like a smaller device?
That's the big question, right?
Yeah.
Can this be scaled down to these resource-constrained environments?
Yeah.
That's a game changer if it can.
Imagine your phone just instantly understanding everything it's seen.
Real-time translation, personalized assistance.
Accessibility for people who are visually impaired.
So many possibilities.
Yeah, so this is just the beginning.
It is. YOLOv12 is a step towards AI that understands complex scenes in real time, not just identifying objects, but grasping the relationships and actions. It's not just seeing, it's understanding.
Okay, so let's rewind a little bit for our listeners who are getting into the weeds of this. Let's talk about some of the specific innovations
Okay, let's break it down.
that make YOLOv12 so remarkable.
Okay, so attention in AI, it's all about focusing on the relevant parts of the data, right? Like sifting through a pile of information and picking out the gold.
Okay.
And traditionally, it just hasn't been efficient with large images, and that's where area attention comes in.
Right, breaking down the library. Yeah, I remember.
Exactly. They limit the scope of attention to smaller areas, so it's less computationally complex without losing that accuracy.
Okay, but the paper also talks about the challenges of training these models, especially as they get larger.
That's where those R-ELANs come in. Remember those support beams?
Yeah.
They stabilize the training process and prevent those gradients from vanishing or exploding, which is a common problem.
And they spent a lot of time actually figuring out how to implement those.
Absolutely. They went through multiple iterations, experimented with different scaling factors, different ways of integrating those features within the network.
So like fine-tuning an engine.
Exactly. Every detail matters. And they didn't just stop at these new concepts. They analyzed and optimized every single aspect.
Yeah, they talked about the attention mechanism itself, comparing different approaches.
Yeah, they looked at linear and convolutional approaches and found that convolutions, which are really good at processing spatial information, actually worked better.
Okay.
So sometimes the tried and true methods still hold up.
Yeah, and it's interesting that they stuck with that hierarchical design.
I know, right? With all the hype around vision transformers.
Yeah.
But their experiments showed that the hierarchical approach with those multiple scales of features just worked better for this task.
So it's all about using the right tool for the job.
Absolutely. And beyond area attention and R-ELAN, they also made a bunch of other tweaks to make YOLOv12 even more efficient.
Okay, so they optimized that MLP ratio within the attention mechanism.
Yeah, they found that a lower ratio actually gave them better performance, and they also got rid of the positional encoding, which is commonly used but wasn't really necessary in this case.
So they really streamlined it.
Yeah, they were all about simplicity and efficiency.
Yeah, and of course we can't forget flash attention.
Yes, the memory optimizer.
It's making sure that data flows smoothly and efficiently through the model.
Exactly. It's essential for making YOLOv12 real time.
So when you combine all of these innovations, what you get is a model that's super accurate and incredibly fast and efficient.
It's a testament to the power of attention, especially when you implement it thoughtfully and optimize it carefully.
It's amazing what they've been able to achieve.
Yeah, and the exciting part is that this is just the beginning.
Oh. Tell me more.
Well, the paper goes into detail about how they fine-tuned that attention mechanism, like they were obsessed with optimization, and it shows...
So it's not just the big ideas, but the tiny details that really make a difference.
Yeah, every little tweak, every parameter, And what's really compelling to me is the potential impact of all this.
Yeah, we've talked about some of the applications, but I think we've only just scratched the surface.
This isn't just a bunch of benchmarks. This is a roadmap to an AI that can understand the world in real time. Not just see objects, but understand relationships, predict actions, even anticipate events.
So it's about awareness.
Exactly. And that's going to lead to robots that navigate complex environments, medical devices that diagnose in real time, AI assistants that anticipate our needs.
It's like a whole new era of AI-driven experiences.
It is, but as we push these boundaries, we also need to think about the challenges.
Yeah, the ethical implications of all this are huge.
We need to make sure these technologies are used responsibly and ethically, but that's a conversation for another time.
Absolutely. For now, let's just appreciate what they've done with YOLOv12.
Yeah, it's incredible what they've achieved, and it gives us a glimpse of what's possible.
It's a testament to human ingenuity, for sure.
Absolutely.
So we've talked about the potential, but were there any limitations or things that surprised you in this paper?
Yeah, one thing that really stood out to me was their decision to stick with that hierarchical YOLO design, instead of going all in on a plain vision transformer.
I know, right? With all the hype around transformers, I thought that would have been the obvious choice.
Yeah, you'd think so, but their experiments showed that the hierarchical approach, processing features at different scales, just worked better for this task.
So sometimes the classics really are classics for a reason.
Exactly. It's a good reminder that there's no magic bullet in AI. You got to pick the right tool for the job.
Right.
But getting back to YOLOv12, there's another interesting detail.
Okay, what's that?
They actually found that by getting rid of positional encoding, which is something that's usually used in attention-based models, they could actually improve performance.
Wait, so less is more?
Yeah, it seems counterintuitive, right? But positional encoding adds complexity, and they found it wasn't really necessary for what YOLOv12 was doing.
Interesting. So they streamlined it and got better results.
Exactly. They were laser-focused on efficiency.
And speaking of efficiency, we can't forget about flash attention.
Oh, yeah, that's the memory traffic controller.
It's making sure that everything flows smoothly through the model.
Exactly. It tackles that memory bottleneck that you get with attention mechanisms. It streamlines how the model accesses and processes data, which is super important for real-time performance.
So they really did think of everything.
Yeah, they were obsessed with optimization, and it shows in the results.
It really does. But what's really exciting to me is the potential impact of all this.
I'm with you there.
We've talked about some of the possibilities, but I think we're just scratching the surface.
This is about AI that can understand the world in real time, not just seeing objects, but understanding relationships, predicting actions, even anticipating events before they happen.
It's like giving AI a whole new level of awareness.
Exactly, and that opens up so many possibilities. Robots that can navigate complex environments, medical devices that can diagnose in real time.
AI assistants that can anticipate our needs.
The possibilities are endless.
And let's not forget about the impact on research and development.
Oh yeah, with a model like this, researchers can explore all sorts of new applications that were impossible before.
It's a whole new chapter in the story of AI.
And a chapter full of promise and challenges.
That's right. As with any powerful technology, we need to think about the ethical implications.
Absolutely. But for now, let's just appreciate what they've achieved.
YOLOv12 is a remarkable achievement. It gives us a glimpse of what the future holds.
It really does.
Okay, so we've covered the technical details, the potential applications, the broader impact. But if you had to pick one key takeaway for our listeners, what would it be?
That attention-based models aren't just for research anymore. YOLOv12 shows that they can be practical, efficient, and incredibly powerful in real-world applications.
It's a game changer for sure.
Absolutely.
And I think it's safe to say that the future of AI is looking brighter and more attentive than ever.
Couldn't have said it better myself. This is just the beginning.
So as we wrap up this deep dive into YOLOv12, I'm curious, what do you see as the next big frontier in real-time object detection?
Oh, that's a good one. I think one area to really watch is the development of even more efficient attention mechanisms.
Okay, so pushing the boundaries even further.
Exactly. Making attention even faster, even less resource intensive.
So we could run it on even smaller devices like smartphones or even those tiny IoT sensors.
Exactly. That would be huge. Imagine a world where every device can understand its environment in real time.
That would be amazing.
Another thing I'm excited about is integrating attention-based models with other AI techniques. Things like reinforcement learning or natural language processing.
So creating systems that can not only perceive, but also learn and adapt and even communicate.
Exactly. Imagine a robot that can identify an object, understand its purpose, learn to use it, and then explain what it's doing in plain English.
Wow, that's incredible. It feels like we're moving towards AI that has a much deeper understanding of the world.
Exactly. And I think it's important to remember as we develop these systems, we need to think about the ethical implications.
That's a really important point.
Right.
We need to make sure this technology is used responsibly.
Absolutely. The future of AI has so much potential, but it's up to us to shape it in a way that benefits everyone.
Well said. This has been a fantastic discussion. Thanks for joining me on this deep dive into YOLOv12. I can't wait to see where this technology goes.
The pleasure was all mine. YOLOv12 is a real breakthrough, and it shows what we can achieve with human ingenuity.
And to our listeners, thank you for joining us. We hope you found this deep dive insightful and maybe even inspiring. Stay curious, and we'll see you next time as we continue to explore the amazing world of AI.